The contribution of physics that our group will present is electricity.
During the early 1700s, Francis Hauksbee discovered electroluminescence, light produced from the flow of electrons. He experimented with mercury in a glass globe generator. This helps in the invention of neon lights. Then in 1729, Stephen Gray and Granville Weller found out that electricity can be communicated over long distances through contact, which is when they use a medium to transfer electricity to another object. This contributes to the research of electrical currents.
Then, Benjamin Franklin proposed that electricity has a positive and negative element, and it flows along these elements. He thought that lightning was a form of electricity, so he conducted the kite experiment. A metal key was tied to the kite as a conductor, and he was shocked from the conducted lightning. After that, Luigi Galvani's assistant in 1781 made the frog's leg twitch with a spark from an electrostatic generator, and from that, he conducted experiments on it more, and discovered that electricity can affect the nerves. From that, he calls it animal electricity. Then from that, Alessandro Volta in the 1800s was inspired to study more on nerves to prove Galvani wrong, and thus created the battery by piling up pairs of metal with the briny cloth, thus contributing the first stable source of electricity. Fast forward.
Then in the 1890s, Nikola Tesla innovated numerous electrical powered machines, including the Tesla Coil, which is supposed to be an innovation that would supply the world with electricity without wires. Other than that, he invented the alternating motor, which turns alternating currents to mechanical power with the use of an electromagnetic induction. Until today, the AC motor he invented and improved still remains as the global standard for transmitting power.
Now that the history of electricity is discussed, let's move on to electricity itself. Electricity comes from the transfer of electrons to another conductive particle, is called an electric current.
For example, you rub your feet on a carpet and touch a metal surface, and then you were shocked. That's because the carpet is an insulator and you and the metal are conductors. That electricity is called static electricity.
Conductors are materials whose electrons can move more often, making an electric current, opposite to insulators which don't that much. A common application of this is in electric wires, where the copper wire is a conductor that transfers electrons to make electricity, and its covers are insulators to control the flow of electricity and to keep us from being electrified. Since copper is highly conductive, inexpensive, highly ductile, and thermally resistant, it is a perfect conductor of electricity.
From the continuous transfer of electrons, an electrical circuit can be made. The electrical circuit is made up of a positive and a negative pole. The negative pole transfers electrons to the appliance, then circulates back to the positive pole.
That's all for this video. Thank you for watching.